Hi, welcome everyone. Thanks for coming. My talk is a little bit about Elastic Beanstalk, which is a service on AWS, and our lessons learned in our journey building a microservice architecture on Elastic Beanstalk. Also, thank you, Rob. There are some really awesome ideas in your talk that I definitely want to take and start implementing when I get back, especially linting all my CloudFormation templates because I hate getting parameters wrong. Cool. OK, so to do next slide. Come on. OK, it's working. Cool. All right. So who am I? My name is Alex. I'm a cloud services engineer at Ocado Technology. You might be familiar with Ocado as the first online supermarket offering home delivery of groceries in the UK. But what you might not know is that we've also developed a platform on the cloud to help us run e-commerce, warehouse management, and delivery services on behalf of supermarkets and retailers both here in the UK and around the world called the Ocado Smart Platform. So what's this talk about? Today, I'm going to go back in time a bit and tell you about our journey onto Elastic Beanstalk, which is in a way the story of our migration to the cloud to begin with, because it's the very first platform we started writing apps and running applications on. I'll talk about some of the challenges that we've had and what we did to solve them, and then maybe a little bit about what we're thinking of doing next. All right. Let's get started. So before diving into the technology itself and how we ended up using it, it's worth explaining a little bit about our use case and what we were aiming to achieve. Also, while most people here are probably familiar with the AWS kind of fundamentals that underpin Beanstalk, such as EC2 or load balancing or auto-scaling, I won't assume that everyone has used or seen Beanstalk before. So with that in mind, what is Elastic Beanstalk? So Beanstalk was launched way back in January 2011. To put that date in context, VAT was still 17.5%. David Cameron's coalition government was still in power, and the news of the world phone hacking scandal had just broken. I was also dossing about in my second year of university. As you can probably see back then, there weren't many AWS products. At the top here, if you can make out the pixelated text, you had S3, EC2, VPC, Elastic MapReduce, CloudFront, RDS, SNS. So Elastic Beanstalk is coming into not a particularly crowded room. If you look at this sort of console page now, it's just a sea of icons that you don't recognize half of. And also, going back to the blog post to find this, all of the images were very small because images were small back then and bandwidth was limited. So Beanstalk was designed to make it incredibly easy to create and deploy and run applications on AWS. When you create a Beanstalk application and you launch an environment, you get EC2 instances, auto-scaling, load balancing straight out of the box, but also a managed software stack that has an operating system, a web server, an application server, all managed for you. As we can see from this rather retro-looking Windows XP screenshot, all it took was a couple of clicks to get a screen like this up and running, which is a running web server with whatever code language you've chosen running. And not only was it easy to launch, but also this should be highly available and fault tolerant and perhaps even horizontally scaling environment ready to go. And this was a quote that was on that first announcing Beanstalk blog post back in 2011. As the name perhaps implies, Beanstalk lets you start on the ground where you're familiar with and begin your ascendance into the clouds. As you start to master those underlying services that underpin it, you can actually start to dive beneath the console and the API and start to fiddle with them specifically. Maybe start tweaking around with EC2 instance types or auto-scaling thresholds or really whatever you wish. OK, so that's a little bit about what Beanstalk was and is, but let's jump forward to where Ocado Technology was when we started our cloud migration. So back in perhaps early to mid 2014, we'd started a major replatforming effort intended to re-architecture our software and amongst other things, make it suitable to run in the cloud. We wanted to break down some of our classic large applications into microservices and enable smooth horizontal scaling, make applications stateless, and start to standardize app-to-app communication as RESTful interfaces between different services. We were also aware of being a little bit ambitious and maybe trying to change too much, so we wanted to stick with some technology that we were familiar with. We wanted to continue to use Java as our main programming language and Tomcat probably as our first web application server of choice. And as you sort of might be thinking, is this turns out it looks like it's quite a good match for what Beanstalk gives you out of the box. Initially, that first application platform that Beanstalk offered was just Java and Tomcat, but now it supports a slew of languages like Python, Node.js, C#, and things like that. So it would be very easy for us to get started, but also some of those constraints around Beanstalk would actually guarantee that we undertook our replatforming seriously. Beanstalk can be very opinionated about you operating a sort of a cloud-native app, and I think this was an intentional design choice on Amazon's part. It really helped force us to change our application's design and avoid any lift and shift temptation that teams might face. As you can see, every service to be a web app or a REST API, and all Beanstalk environments that you create are themselves web applications, web servers. We wanted all services to be able to scale horizontally. Anytime you create a Beanstalk environment that has not just a single server, it has a default auto-scaling policy ready for you. Also, we wanted applications to be stateless, and this is something that auto-scaling definitely pushes you towards, because as those thresholds start to get hit, you see yourself replacing instances, bringing them in, taking ones out. If those have a load of application state on them, you're going to find yourself in trouble to begin with. So there was also a bit of learning in that not every app is a good fit for Beanstalk. I know this to be true because for one of our more complicated applications that optimizes the routes of home delivery vans, we opted not to rewrite this at the time of the migration. This application does a lot of work in memory, uses quite big instances, and each node of the app gets assigned a geographic zone and a day in the future. This means if we had 10 geographic zones and we wanted to offer delivery slots 3 weeks ahead of time, we would need 210 nodes. As you can see, it doesn't really fit Beanstalk's model. We needed to do things like circumvent load balancing so that you could address individual nodes to send them updates. We needed to set fixed minimum and maximum auto-scaling capacities so that all the auto-scaling was really doing for us was maintaining that capacity, replacing a node if one became unhealthy and dropped out of service for whatever reason. So with some applications, you would lose a lot of the benefits of Beanstalk, but you still gain benefits from a lot of the orchestration and APIs that allow you to quickly stand up environments. So with all that in mind, we started our migration, which was less a migration of existing resources and more of a development of this brand new platform on Beanstalk. Also, there's one quick thing that's worth mentioning, and that's the Beanstalk is just an orchestration layer on top of existing AWS services. So these are all the IAM permissions that you'd need to give someone to give them full access to Beanstalk. This is in the Beanstalk full access, I think, IAM managed policy. And as you can see, it's quite a lot of things that you have full access to. Things that we definitely wouldn't just want to give to all our developers, fully. So instead, we placed all of these permissions inside of dedicated roles for each application, and also started to play around with how well they could be namespaced. So removing a lot of the sort of all-resource star statements here, and slicing them up to individual namespaces for each app. And this is separate from the application role as well. This is not the permissions the app has when it's running. This is the permissions used to deploy it, because generally I don't believe that applications should be able to deploy themselves unless they've come up with a really good use case for why that's a good idea. We also didn't have people calling the Beanstalk API directly, or at least not developers. We wanted to build an API of our own to stand in front of it. This way we could abstract away a lot of parameters from developers, make things a little bit easier for them to get started with, set in some sensible defaults as well, and allow us to change things over time. So how does that all sound? Do we think that was all good? Not exactly. This would be quite a short talk if that was the end of it. As with any solution, there are going to be some challenges, and this kind of promise of you just provide your code and we do the rest, it's true when you're getting started, but as you start to fill out to a larger scale, you start to run into some more of those challenges. And we definitely had a few that we needed to adapt to, as nothing is ever as easy as first promised. And if anyone is considering using Beanstalk at kind of a full enterprise scale, these are the things that you might want to consider, and some of the ways we ended up solving those problems. So did we have too much of a good thing? Were we trying to cram too much? We have, all told, I think around maybe 328 microservices in one of our largest accounts, which ends up with over 300 Beanstalk applications, and they generally, on average, have maybe around 2 environments. at any one given time, maybe more if there's a lot of development going on in lots of separate branches. Now, some of these are test apps and not part of the core microservices in the platform, but they still needed to be deployed and operated all the same. As you can see from this picture, the Beanstalk console on Amazon is quite sparse. If you have lots of applications, this is going to be an incredibly long page. And also, there's little things like the filter element in the top corner there starts to get a little bit unresponsive once you have a lot of apps. And there's no pagination or things like that. There are other parts of the console, like EC2 and load balancing and security groups, which are really optimized for having thousands of resources. But Beanstalk doesn't necessarily feel like that. It feels like it's good when you have single to low double-digit number of applications, and becomes a little bit tricky when you increase that number. Also, the AWS console still uses those APIs under the hood that you would end up calling programmatically. So as you might know, AWS can throttle API calls if you start to really hit them at a rapid rate. And they have a justified reason for doing this. They want to potentially protect their other customers if it looks like you could put the performance of various services at risk. And we started to see throttling issues, and we'd have a large number of developers logged into the AWS console, just looking around or trying to observe their app, and this might negatively impact ongoing deployments. This is a sort of a bit of code just to try and sort of catch things like throttling exceptions and retry something that we build into almost every piece of code we have that calls an AWS API. We also had multiple AWS accounts spread over multiple regions, and part of which is to sort of manage that aforementioned throttling issue. And rather than having users switch between different accounts, we wanted them to be able to see the health of all their resources on each one. So what do? We built our own dashboard application that would span across all these different accounts. This gave us a chance to make API calls on behalf of the developers, and then we could cache the response for up to 60 seconds. This drastically reduced the number of API calls that we were making. And it made it really easy to switch between different environments here. You can switch between production and dev and accounts for different retailers. And also filter applications by search and by health as well, if you wanted to only see unhealthy applications, for example. Here's one of my environments for one of my applications. As you can see, I've got all the detailed info that I would expect from the Beanstalk console API. So this is the Beanstalk console or API. So this is some of the health of my instances, when they were launched, some latency and load information. But I will also be able to get things like the event stream or the current Beanstalk configuration. Another thing that this allowed us to solve was another one of our permission issues. We wanted to allow developers to be able to fetch logs from production environments without giving them all the IAM permissions that you need to be able to do this, such as writing to S3 buckets. And also, importantly, this whole application is something that we can continually iterate on and improve for our developers. There are loads of custom features like links to deployment actions or being able to group apps by teams, things that probably wouldn't ever be added to the AWS console because it needs to remain generic and approachable for all customers. All right, so with that solved, on to the next challenge. This one is probably the most broad and is something that you might have to face whether or not you use Beanstalk. And anyone that manages a large number of instances has probably run into this issue, and that's the idea of configuration management. So beyond the essentials that Beanstalk provides you with, that operating server, the sort of language interpreter, app server, web server, there's always some additional software that you're going to want to end up installing on your instances. Maybe it's a New Relic agent or some other monitoring tool or daemon, maybe some Python scripts for debugging, something like that. And previously, I'd use tools like Puppet to solve this information, or like Ansible or Chef that you might be familiar with. But there was a little bit of hesitance, and some people have had some poor experience running Puppet in the past and worried that it was slow, or what happens if the master gets down, or things like that, and it being a bit of a configuration challenge. So we turned to a service that Amazon provides, which is using the Amazon machine image. Here we could use something like a masterless Puppet to build a machine image, and also using tools like Packer from HashiCorp. And then we could say, to developers, here's the machine image. It's got all the base stuff you need on it, New Relic and all that stuff. And you can just run from here, and Beanstalk can work with it. And while I wouldn't say that there's anything wrong using AMIs to create master images per se, and other companies have used it, and there's some great tools out there like Spinnaker in the open source environment. I would say that if you're thinking of using them, you definitely want to commit and make it a really core part of your automated continuous integration deployment pipelines. So what do I mean by this? It kind of comes down to release cadence. If you're thinking of building an AMI every couple of months and saying, yeah, we'll just update it, that probably won't work. Amazon typically releases a new solution stack for Beanstalk once every 2 weeks, and they do that for all of the languages they support. So you probably need to make sure that your AMIs are keeping up to date with that. Otherwise, you'll be missing out on critical security patches, up-to-date versions of Java, Apache, Tomcat, things like that. As I said, solution stacks are unique for each programming language, so if you're using them, you need to build an AMI for every language you support, which might be fine if all your developers use Java 8, Tomcat 8, but we very quickly started to have people wanting to use Node.js, Python, even Docker, and have these applications to support. There's also another way that you can customize the software on Beanstalk. This is something that runs on startup, and it's called EB extensions. It's a very lightweight configuration management solution that lets you specify some sort of simple fundamentals to an instance, like packages, files that you want, commands that you'd like to run, services, things like that. And these are things that you want to install or create or run on your instance just after it's booted up. And our developers can provide these as part of their bundled zip of their source code, their artifact. So they have this little .eb extensions, and they say, I'd like you to write this into my Apache configuration directory, write this file, or install this yum package or this gem or something like that. And this was really great for developers because it did allow them to make those little small changes without having to have them affect other people or be sweeping and affect everyone else. But it wasn't yet something that we could use because developers are providing this with their source code, and if we were to try and get into that, we'd have to sort of explode their compressed zips and start injecting files and things that would sound a little bit complicated. And our existing AMI solution, although a little bit of a pain to continue to build and maintain, was working so far. But then, at some point, Amazon released a new feature for Beanstalk, which I actually think is quite poorly documented. I tried to pull out some blog post or find this in documentation. It was a little bit tricky. But effectively, it's called external EB extensions. And on the face of it, sounds very simple. You specify some S3 keys, and it'll draw from that for your EB extensions rather than what you've provided in your zip file. But for us, this was a really good idea because you could actually have both. A developer could provide some instructions to run as part of their code deployment, but we could say, when you deploy using Beanstalk, as I mentioned, we've got this facade API, we could say, also, could you install our admin EB extensions, things that everybody needs, like the New Relic Java APM and things like that. This was great for us because the whole EB extensions process piggybacks onto Beanstalk's bootstrap process anyway. So Beanstalk is already running a load of hooks at startup to install its dependent software, install things like Apache and Tomcat and things like that. So it's a very easy process. And at the end of doing those install steps, it goes ahead and runs the sort of user-provided ones. So you don't really add much to your deploy time to be able to run some kind of nice, simple, lightweight configuration. And because of this, we were able to move back to the vanilla Amazon Linux AMIs rather than our baked AMIs before. And we just needed to do a few files and package installs to get to where we wanted to, which was, for us, a real help with security. And we're able to simplify and do away with a lot of our build pipelines and distribution of images. There's another great feature that I sort of want to draw attention to, and that's managed updates. If you find that you've been deploying to an existing environment for a long time, or your code hasn't changed in a long time, and you want to have some of that provided software like Apache and Java updated, maybe sort of AWS has released a couple of new solution stacks, but your code hasn't changed, you can schedule a window of time in which you'd like to have that managed update take place. You can also specify that you want to replace your instances when you do this. So that means any startup processes that you have get to be rerun. And you can avoid any issues that might come from running a server with a very long uptime. I know as the infrastructure community, we can become very proud of having servers with a really long uptime. But the more frequently you rebuild a server, the more confident you become that it can be rebuilt at any time and returned to a previous known good state. So instead of having to go into the console or use the API to make these changes, you can say, I want you to do this at 10 o'clock every Monday or something like that, if you have any updates to do. Sometime when you'll be around in the office and can see it. But it is reasonably safe to do. It uses auto-scaling to bring in new instances and successfully deploy your application. If, for example, a minor Java update or patch did cause an issue with your code for whatever reason, you'd expect your application not to launch. Things like the health check would fail, and Beanstalk would go, OK, that's fine, I'll roll that back. We failed to apply this update. I'll probably make a note in the event log, but other than that, it's not going to take down your app. So you could schedule this in production. You should schedule this for in the night if you're feeling very confident. OK, so it's starting to look promising so far. We've taken some of that ease and automation that was promised to us by Beanstalk, and we've worked our way through some of those initial teething problems. We've worked out how to ensure images are being up to date and the best way to use them. We've provided a way for developers to have safe and sensible access without needing to direct access those APIs. There's questions about how can we use it at scale? How can we keep our software patched up to date? So we thought we were in a relatively good position. That was all we needed to know. So what do we think? No, not quite. So I was looking at things like solution stacks and AMIs and being pretty confident that this was all up to date and secure and we were good. So one of our security engineers sort of saw this and came to me and said, oh, there's this new AWS service called Inspector that you can run on your instances, and it can report on vulnerabilities that he wanted to try. Previously, we've been using Amazon Linux security advisories to get an idea of what vulnerabilities had been announced and trying to push developers to relaunch their instances, make sure they're up to date. One of the things that we're running on startup is just patching yum packages effectively. And this was driving our effort to kind of push towards latest solution stacks. We thought that was the solving grace. However, after we installed the AWS Inspector agent and ran it on every instance, we found that there was a slew of CVEs that it reported, which, if anyone's not familiar with the term CVE, it stands for Common Vulnerabilities and Exposures, generally publicly vulnerabilities, publicly announced and released vulnerabilities that you have in your code or your app. So what was going on here? So this is an Amazon Linux security advisory. It might be a little bit small for some people at the back, but we're running Amazon Linux, so we believe that this is how we keep our instance patched. And it has a issue correction or remediation section. And this says, run yum update kernel, and then reboot the instance to update your system. And you go, OK, well, that's great. I'm using this version of Amazon Linux, the most up-to-date. This is what I need to do. I can patch myself. That doesn't actually turn out to be the case. So even if you're on the latest generation of Amazon Linux AMI, and historically these have released about once every 6 months, it's not as simple as that. So it turns out, if you're running on your own EC2 running Amazon Linux, you can get these up-to-date patches, but you're still responsible for making sure all your software plays well together. You're responsible for testing that. If you use EC2, Amazon is a compute provider. It's your responsibility, everything that happens on the box. You have root access after all. But with Beanstalk, because Amazon is providing a lot of the fundamental software for you, Java, Beanstalk, Tomcat, Apache, they're promised that everything works. They need to test that that works together. So when a patch comes out for Amazon Linux, it isn't immediately available for an existing solution stack of Beanstalk. These are in fact locked to a sort of a dated Amazon repo that was true at the time this was released. And there's a sort of different judging of severities. The Amazon Linux Security Advisory doesn't exactly match CVE criticality, but there is a close connection there. And we've definitely had issues in the past where something that's considered important, from having a CVE announced all the way through to actually a new solution stack being released for Beanstalk and it being patched, might take up to a month. So that's one thing to be aware of. If you have really critical deadlines about how quickly you expect software to be patched, if you have something that's a publicly exposed Beanstalk web server and you say, yeah, we patch critical vulnerabilities in 48 hours, you make that promise, it's not impossible. There are ways around it. You could definitely find a way to download and apply that patch yourself, not using Amazon's repos that they connect to Amazon Linux. But you may be throwing away the opportunity to complain to Amazon when something doesn't work. Obviously, you're free to kind of pull out RPMs and things like that, host them in S3, and install them when you boot up. But you are still solving the problem of patching individual bugs rather than having, or individual vulnerabilities, rather than having a smooth, comfortable experience every time. I'm aware I'm fairly close to running out of time, so I'm going to try not to drag on too long. The next section is more some general architecting advice. This is a little bit more about maybe some mistakes or misassumptions we made with our initial architecture goals. This isn't strictly specific to Beanstalk, but it plays a lot on the way we thought about designing microservices and how we ended up doing that on Beanstalk. So one of these is blue-green deployments, which was the strategy we wanted to choose for deployments. In short, this is a deployment strategy where you create a brand new environment with your new application version running on it, and then you redirect traffic from your old version to your new version. There are loads of advantages here, and it's very quick to revert back to a previous version. You simply redirect the traffic back to your original servers. You can also test against your new version in production before putting it in front of real customers, just to get that extra level of confidence. And Beanstalk very much supports this deployment style. There's a simple API call to swap the URLs between two environments. But there are some issues, there are some things to be aware of. Because you're just swapping a URL, you're effectively relying on a DNS swap. You're kind of depending on the clients to honor things like your time to live, your TTL for those records. And if they don't, you could see a long tail of clients using the old version of your application. If you've made a quite major change, it actually might be quite problematic for two versions of your code to be in play at once, making calls against the same database, for example. So some of the solutions to this are, well, first, maybe try and control all your clients of a service. So for internal microservices that talk to each other, this is great. If you're talking about an external web server that is available to clients outside of your control, specifically mobile clients, which are notorious for not really honoring TTLs, maybe you want something that has a non-changing DNS records, uses the same load balancer. There are some other deployment strategies as well that aren't this, that do reuse the same load balancer, like a rolling update. But you lose some of your benefits maybe about being able to quickly back out or test your code before you've run it. One other thing we've noticed is kind of consequence of our microservice strategy was trying to find the right sized instances for our apps. So imagine a microservice that is responsible for updating the email templates used for customer comms. In the past, this was probably bundled into a big comms app, and that was the end of it. But now, in our modern architecture, we've done it very sensibly. We've got a web front end, actually two microservices. We've got a web front end and a back end API. But imagine how infrequently those are actually used. People aren't changing their comms templates to their customers that frequently, maybe once a day. But having it sitting there, being highly available, two instances, load balancers, scaling, ready to go every day is starting to incur flat load balancer costs and flat instance costs. So it may be a pleasant code base to work on, but does the cost of having an independent microservice justify that? Could it be co-located with other services? Maybe not the code base merged, but running as a Docker container. Could it work on something like AWS Lambda if it's only invoked very frequently and executes quite quickly? So we started to have a look at things like cost-saving ideas as well. This initial microservice architecture had a lot of nice features, but had a lot of expense. As I say, every service of those 300 has its load balancers. That's quite a lot of cost. Everyone's got at least two instances. So initially, we did things like stopped running EC2 instances overnight in non-production environments. It seems like a very sensible, logical step. Purchasing reserved instances for instance types. This is where you pay up front with Amazon, and you get a discount over the course of a year for running your instance. Also, once we were able to, Beanstalk had a feature that let you restore a terminated environment. Now, when this was probably released, they thought, oh, this is great if you've accidentally terminated an environment or you need to get something back quickly. No, what we did was we terminated all our environments at the end of the day, saved those environment IDs in S3, in the morning, started them all up, which I don't think was the intended use of this service, and it actually ran us into some issues with the next slide. Another great thing to use for these small microservices that don't receive a lot of traffic is the T2 instance type. T2 instances, you get a portion of a virtual CPU, and you start to accrue credits in which you can use this over time. So maybe you use 20% of one CPU constantly, and then or you could use 5% and burst up to 100 for a couple of minutes, consuming your credits. One of the problems we had is we were starting so many new instances. Now, instances start with an allocation of credits, but in order to stop you gaming the system here, whereby when your instance runs out of credits, you terminate it, or scaling brings up a new one, or it's got an allocation, you get a fixed number of these launches, per rolling 24-hour period. But also one of the issues is when you terminate an instance, you lose any credits you've accrued. And we were terminating instances quite rapidly, as I said, doing blue-green deployments, bringing up environments, tearing them down, scaling. So we ran into a kind of bit of a trap here where we could run out of credits, and then everybody's deployments was taking forever, and we couldn't work out why. And all we could say was, just wait until we get more. Then this isn't also one of those kind of visible AWS service limits that you can just fire off a support ticket and have raised. But if you are thinking of using T2 at a large scale, if you have a technical account manager, definitely talk to them and try and understand this limit on the back end and how it might affect the Beanstalk service team. And they may be able to change and make various provisions for you. There's also a new feature called T2 Unlimited, where you can effectively say, if I run out of credits, keep giving me CPU, I'm happy to pay additionally, which is a nice feature that you can do to kind of rescue environments or instances that get stuck in this sort of low credit dead end. So what's next for us? So I think what we've experienced over using Beanstalk is it's a really great service, and I do love it, but it doesn't need to be the one-size-fits-all solution to all your problems. I mentioned we had this API that we're using for deployment, but we're trying to spend a lot of time enriching this and generalizing it so it can be used to deploy not just Beanstalk applications, but other types of deployment types. Maybe generalize the API so that developers aren't necessarily worried about, is this running on Beanstalk? Could it be on Docker? Could it be on ECS? And just an API which kind of supports a generalization of those parameters. So this is our new service. And also, people love stats, so I try to make sure there were some stats included in this talk. It's called Chancellor. And at the moment, we can see we're doing about 2,500 deployments a week using it. So it's a fairly strong user of the Beanstalk API. And there are other actions there as well, which include things like configuration and properties deployments or API gateway deployments. That's all drawn together under a single API. And we're down to about an 8-minute average deployment time. As I said, people are starting to find different deployment strategies to use. So blue-green, rolling deployments, immutable. One we call Highlander, which is where it brings up a new environment, swaps over, and takes the other one down immediately, which you might be able to work out why. And also, yeah, there are other services out there. As I said, there's not one-size-fits-all solution for all your apps. Beanstalk's a great center point. It's a great starting point. But you might want to start exploring things like Lambda. I hear serverless is incredibly interesting. I don't think you can ignore things like ECS and Kubernetes if you're serious about infrastructure and how to run services. As we said, some services are called very infrequently and execute quickly. These could be Lambda functions. Some services have really low CPU. Or variable CPU and RAM requirements, which as containers, we could form the perfectly sized container that fits that. And also really slim front ends, maybe that's just better off as a static app running on S3, and it can call those APIs in a JavaScript framework like React. So yeah, what are my sort of recommendations that pull together this talk? Know that the AWS console is not always going to be the best tool to visualize things. Don't be afraid to maybe build a quick dashboard that gives you a quick win and improves productivity. Think about how important security patching is going to be for you. If you need to really ensure there's a quick deadline for how quickly a patches get applied, actually validate that you're meeting that. Use tools like Inspector to see that vulnerabilities really are patched as soon as practically can be after they're available. Also, pursue the whole microservices vision, sensibly. There's a lot of hype and, popularity around microservices, and, very, very good idea and a massive improvement over the monoliths of the past, but apps can definitely become too small or become very expensive for being small. Think about the costs of giving every app a load balancer, redundant auto-scaling group. As a final point, be aware of that I didn't finish typing. I'm going to assume that's one of the things I mentioned earlier. Be aware of things like, CPU credits and T2 and things like that. All right, drawing to the end, this is my conclusion. Beanstalk's a pretty great service, but like all promises of the cloud, it has its limitations. Find these, know them, and learn to love them. Thank you very much. Cheers.